The first session of today, we're going to be learning about Deepwater Horizon projects on federal lands and waters. And I'm very pleased to welcome Mary Josie Blanchard, who will introduce our fantastic panel to you. Mary Josie is the Director of Gulf Coast Restoration for the Deepwater Horizon oil spill in the Office of the Assistant Secretary for Policy Management and Budget here at Interior. She has previously served as the Deputy Director of the Office of Environmental Policy and Compliance, and as the Assistant Director of the Office of Surface Mining, Reclamation, and Enforcement. Mary Josie received her BA and her MA from the University of Texas, and Mary Josie has also received Interior's Distinguished and Meritorious Service Medals. So welcome, Mary Josie. Thanks so much for joining us today.
Certainly, I feel like I've just had a trip to Hawaii for a little aloha. So I wanted to extend my appreciation to Emily for giving us the opportunity to share, and to all of you in the audience who are listening in for our updates on the Deepwater Horizon oil spill. Personally, I find it hard to believe that April 20th, 2025, it's been 15 years since the tragic loss of life that occurred during the explosion and the oil began spilling. It spilled for 87 days and cleanup took several years afterwards. The cleanup was underway, early restoration began, and after the settlement in 2016, then began the long-term restoration. As with any NRDA case, our restoration activities are guided by the consent decree and other associated documents. Funds were divided up for our part into geographic areas for trustee implementation groups and restoration categories. For example, in the consent decree, allocated $75 million across the various TIGs for restoring habitats on federal lands. The TIGs have funds for migratory birds, sea turtles, recreational opportunities, and several other categories. Funds for these can also be used on federal lands and waters if the TIGs choose to do so. And as with all the other NRDA, everybody sings Kumbaya and goes in the same direction together. As of April 15th, the trustees have committed $42.2 million, or 56% of the funds, to restore habitats on federal lands. When you take into account the projects funded for other restoration types that might have benefits to resources on federal lands and waters, nearly $450 million has been committed to restore these injured lands and the resources that we use to provide for them. We don't have time to go over each of the 60 projects, but the annual reports are scheduled to be published later this month. Today, I have 4 dynamic speakers that will give you an overview and update for a few of the activities and projects that have benefited resources on federal lands and federal waters. The first is Sophie Williams, who will talk about North Breton Island Restoration. Sophie's a biologist and project manager with the U.S. Fish and Wildlife's Gulf Restoration Office. She received her master's in geography for the University of Alabama. She contributes to restoration project implementation, spatial analysis, and partnerships that benefit the Gulf of America, fish, wildlife, plants, and other habitats through restoration. Kelly Brooks, from the great state of Texas, will discuss the McFadden Beach Nourishment and Dune Restoration Project in Texas. Kelly is a project manager with the Coastal Erosion Planning and Response Act program, CIPRA, and in the Coastal Resources Division of the Texas General Land Office. Kelly joined the GLO and CIPRA team in 2016 to work with the federal and state agencies, local coastal communities, and nonprofits to promote and help facilitate projects and studies to combat coastal erosion and restore degraded habitat. Our third speaker is one that's familiar to probably most of you. Mark Van Maurik will talk about the Johnson Beach access and habitat protection at the Gulf Islands National Seashore. He's worked on the restoration project manager for the Park Service's NRDAR program in Fort Collins, Colorado since 2002. He's been heavily involved with restoration work related to the 2010 Deepwater Horizon oil spill, primarily at Gulf Islands National Seashore. And our fourth speaker is Amanda Demopoulos, who's a research benthic ecologist with the U.S. Geological Survey at the Wetland and Aquatic Research Center in Gainesville, Florida. She conducts research on community ecology of coastal wetlands, seagrass habitats, shallow and deep sea coral reefs, and seeps. She serves as Interior's liaison for the Mesophotic and Deep Benthic Communities Restoration Portfolio. She assists with coordinating the science activities planned for Interior and NOAA. Please save your questions till after the last speaker, and I'll now turn the presentation over to Sophie. Thank you very much for your time and interest.
Good morning, everyone, or good afternoon, depending on where you are. Thank you so much for the introduction, Mary Josie. I am excited to present an overview of the North Breton Island Restoration Project today. We'll start with some project background before talking through information on project implementation, monitoring, and next steps. First, let's get oriented here. North Breton Island, just under the yellow pushpin, is located off the coast of Louisiana, here just above the Bird's Foot. It's a barrier island located at the southernmost tip of the Chandeleur Barrier Island chain, about 13 miles off the coast. It's part of Breton National Wildlife Refuge, which is managed by the U.S. Fish and Wildlife Service. North Breton Island is recognized as a globally important bird area that hosts one of Louisiana's largest brown pelican nesting colonies. During the summer, the island provides breeding habitat for pelicans, terns, skimmers, gulls, and other nearshore shorebird and seabird species. During the fall, spring, and winter, it provides foraging and overwintering habitat for other migratory species. 93 species of birds across all 5 Gulf state and federal waters were impacted by the Deepwater Horizon oil spill. Because of the significance of its habitat, North Breton Island was quickly identified as an ideal site for restoration. So the North Breton Island Restoration Project was approved back in 2014 during early restoration phase 3. It is one component of a larger Deepwater Horizon settlement-funded project, the Louisiana Outer Coast Restoration Project. In addition to North Breton, 3 other barrier islands were restored through this project: Cheniere Runke, which is implemented by NOAA, Shell Island, which is implemented by Louisiana CPRA, and Calu Lake Headlands, or Whiskey Island, which is also implemented by CPRA. For the North Breton component, DOI leads project implementation through the U.S. Fish and Wildlife Service. It's important to note that the North Breton component also has additional funding in restoration achieved by combining Deepwater Horizon funds with a separate settlement, the 2005 Hess oil spill settlement. Because of this project scale and multiple components, it's a very interconnected project. It has many federal and state partners, including a combination of the standing partnerships of the Louisiana Outer Coast NRDAR project and the Hess Trustee Council. At every stage of planning, engineering and design, implementation, and now monitoring of this project, our partners have been essential to our success. And I'm very grateful for their continued expertise and support in my work. So before restoration began at North Breton Island, the island appeared as shown in this photo, which was taken just before construction began in 2020. The island was about 290 acres in area, and overall elevations were quite low, with most of the island around 2 feet above sea level. There was some black mangrove and march vegetation in the back barrier zone on the island's north end, but overall habitat used by bird populations was in decline. So to counter these conditions, restoration techniques included placement of dredged fill material within the island footprint, installing sand fencing, and planting native vegetation to expand raise, and stabilize the island area. These efforts will help accomplish the project's goal: increase available nesting and foraging habitat for birds. And so this is another aerial photo taken before restoration began, where you can more clearly see the low elevations and effects of erosion on the island's area. The construction phase of restoration began in 2020 and took about 507 days to complete. Despite a setback from Hurricane Ida, construction wrapped up in 2022. This phase of the project expanded the island area by about 100 football fields and raised overall elevations. In the spring and fall of 2023, native vegetation, including thousands of bitter panicum, sea oats, and black mangroves, were installed in the dune and back barrier marsh areas. And this image highlights some of those plantings that were put in along the dune. And you can also see some colonial nesting aggregations of terns and other bird species foraging and loafing. And here's the before and after satellite imagery in one place, where you can see how the island footprint expanded and elevations were raised overall. The monitoring phase of the North Breton Island Restoration Project began in 2022 and continues through 2031. The monitoring plan arranges for long-term habitat and bird monitoring for all Louisiana Outer Coast project components to help assess restoration outputs. Habitat monitoring involves measuring vegetation survival and cover, habitat acreage, and several conditional parameters, including island breaches, shoreline position, and sediment volume. Bird monitoring techniques include ground and aerial surveys. Aerial surveys use unmanned aircraft systems and fixed-wing methods to gather photographs of the island during nesting season. Nests, breeding adults, and fledglings are counted in the photographs to estimate nesting and productivity. In the spring and fall, ground surveys help measure habitat use by overwintering birds. And so in accordance with the Monitoring and Adaptive Management Plan, our project team collects many types of monitoring data in the field, including those aerial images of nesting birds, elevations, and vegetation survival and cover. So looking forward, we have a few near-term goals as we continue working on this project's monitoring phase. Between 2025 and 2026, we plan to implement a second native vegetation planting in the dune and back barrier marsh areas to further stabilize the island and increase recruitment of our plantings. In partnership with USGS, we are also working to develop a data visualization web tool, which will provide the public with easy access to and interpretation of monitoring data. We also plan to continue investigating opportunities to leverage new technologies and methodologies into our workflow. And this includes using unmanned aircraft systems and machine learning techniques for bird monitoring. We've learned a lot along the way while working on this project. The first lesson is demonstrated by the HES addition to the settlement funds. Leveraging funds from two different settlements helped offset the high cost of construction mobilization to the island and maximize the amount of restoration we were able to implement. Other important lessons include adaptability and flexibility, which have helped manage challenges from hurricanes during construction to scheduling fieldwork for monitoring. Perhaps the most important lesson, though, is the value of partnership. Having a supportive, communicative, and expert project team helps foster project success at every step of the way. This was a super brief overview of a very big long-term project, and there is so much more I could and would love to share about it. If you're interested in learning more, please visit this project's page on the Gulf Spill Restoration website, or feel free to reach out to me anytime with questions. Thank you all for your time and attention, and I will now pass the mic over to Kelly Brooks with Texas GLO.
Thanks, Sophie. What a great presentation. Let's see, my camera wasn't working. It's okay. All right, I'll switch over. Okay. Sorry. Sorry, it's loading the file. Apologies. Okay, that's taking too long. I'll just go to regular presenter. Right. Share this one. Okay. Can everybody see that the presenter was not working? Apologies.
Yes.
All right.
Good.
Awesome. All right. Thanks, Sophie, for the introduction. And thank you all for letting me join and talk about another large-scale project that happened on the tail end of Sophie's project. So the McFadden National Wildlife Refuge Beach Nourishment Project. My starter page is very busy because this project had so many stakeholders. Shout out to our federal partners at DOI, USDA, EPA, NOAA, U.S. Fish and Wildlife Service, and of course the Refuge Service. And then our state partners include TCEQ, Texas Parks and Wildlife Department, the Texas General Land Office, Jefferson County, and we also had funding stakeholders in NIFWIF and Restore, and of course NRDAR. So the McFadden Beach and Dune Restoration Project is located at the McFadden National Wildlife Refuge, really close over there next to our friends in Louisiana on the Bolivar Peninsula and Chenier Headlands. Right behind it is a very important salt bayou. It's our largest continuous marsh system. It provides a vast amount of ecosystem services for all kinds of flora and fauna, including it being a major stopover for migratory birds. This is a very big area for birding and all kinds of things. At the same time, this area has been very, very ravaged by, just like our friends in Louisiana, this is the hurricane highway. So this project was really needed to restore up to 17 miles of beach and dune system. Once again, this used all three Deepwater Horizon funds, so NIFWIF, NRDA, and Restore. It is the largest beach nourishment project ever completed in Texas, lengthwise, and the amount of material that went into it. And this was chosen as the Deepwater Horizon Texas TIGS restoration plan. It was from the first restoration plan, it was a priority project. Currently, we're in post-construction monitoring. That includes water quality monitoring of the Barrow area, where we took the sand from bathymetry and topography of the Barrow area and the beach placement. And then we're doing, of course, periodically going out there to see and monitor everything and see what's going on. Okay, so why is this needed? So here's some pictures of what the shoreline looked like pre-renovation. And of course, we had tons of lessons learned. So this bottom right image, this is remnants of Highway 87. Highway 87 goes along, traverses the entirety of the Bolivar Peninsula, and used to go all the way to the end of Texas up to Sabine Pass. But like I said, this is where we are inundated with water from high tidal events from tropical storms and hurricanes. And so by the 1980s and 90s, this portion of Highway 87 was completely taken out. In the upper left corner, you can see how the Gulf of Mexico is just completely on top of these really important wetlands. There is usually no beach whatsoever. And the top right, you can see these clay outcrops. It's pretty neat. Well, it's not great, but these clay outcrops are very, very old, boggy conditions, extremely fat clay. You get stuck. That creates all kinds of problems. So this shoreline has largely been unrecreational for at least 25 years, if not longer. No sand left, little to no sand, lots of clay. And that's just not a great ecosystem for beach ecosystem services, nor does it provide any kind of protection for all the critters that live there or in the swash zone. So This project was really integral into restoring and creating some sort of buffer for that salt bayou marsh behind it. Okay, so efforts to restore this shoreline included efforts by Jefferson County, the Salt Bayou Working Group, and GEO-led initiatives. So you can kind of see that shoreline again up in this top left corner. Sorry, get that out of your way. Here's that old remnants of Highway 87 and just absolutely no shoreline. Definitely cannot drive down here, although lots of people still try to. That ends up with lots of derelict vessels and or, trucks. You have it just abandoned all over the shoreline. So back in 2015, the GEOLO in Jefferson County and U.S. Fish and Wildlife Service constructed a clay berm that traverses about 500 to 1,000 feet behind the beach. There's a large levee system that just parallels the shoreline with the intention of it stopping any kind of overtopping events from the Gulf of Mexico. Then in 2017, we also completed a beach and dune restoration project that we call the pilot project. Because the National Wildlife Refuge is 20 miles long, has really no access because the highway is gone. We wanted to do a smaller scale project in order to figure out all the difficulties we would have. So in 2017 and 2016, we completed a 3-mile section utilizing a borrow area offshore and pumped that sediment to the beach and learned a lot of things that we took into the next phase. So the next phase included 3 different fill segments. In the bottom right corner, you can see these fill segments. So they go from Chambers County through Jefferson County for fill segment 1. That was a beach template of up to 40 cubic yards per linear foot. Here's what our beach template looks like up here with a nice dune bridge at +8 NAVD, a beach berm that starts at +5 NAVD, and then really looking at restoring the beach in an economical and effective manner, something that we could also afford, right? It's not like we have tons of sand just at our will where we can just like throw it on the beach. And so having to do such a large project, we had to pick and choose like where were we eroded the most, what did we need to do? So the pilot project, because it had been previously nourished, was a great monitoring place for us to look at, but it was not chosen for additional nourishment. And then fill segment 2 had a slightly larger fill template, and this was up to 48 cubic yards per linear foot. And then fill segment 3, closer to our friends at Searim State Park, run by Texas Parks and Wildlife Department, is a bit more stable, or was a bit more stable. So we had it on the end with only 10 cubic yards per linear foot. And so all those cubic yards per linear foot are what go into your cross-sectional templates. And that is how engineers and coastal planners plan how they're going to effectively restore these beaches. Okay, so a little bit about this shoreline. It is a wild, wild place. It is the juxtaposition of oil and gas and energy, midstream, the whole gamut in Port Arthur. And then it's also the inception of like the oil boom in Texas and, pretty much like the US with Spindletop. So we've got pump jacks on the uplands. You've got massive abandoned, derelict oil and gas structures. This is Vastar, former BP. You can see these huge pipelines, all this old infrastructure coming in. This is an abandoned separator. So not only is it important for us to accommodate erosion and try to combat it, but it's really important as far as coastal hazards, because as we erode back into these anthropomorphic systems, where we have like changed the earth and we have put in pump jacks, that is a whole other thing that we're dealing with. And, of course, we're talking about NRDAR, so oil and gas and spills and things like that. So this is part of that project, is analyzing how do we make this a better place at the same time. So with all the abandoned infrastructure, we just have massive amounts of oil and gas infrastructure left behind. So the first part of this was a massive debris removal project along about 20 miles. So things were identified. And as we have such an advanced erosion here, these things become completely, as we move landward, these things just get buried with seawater and they just remain offshore. So by the time we got to the project, we worked on what we could, but ended up removing a whole lot of really dangerous hazards for the public. Another uniqueness about this project is we utilize a borrow area that's located 1.5 miles offshore. This is the same borrow area used in the 2016-2017 pilot project. It is a Pleistocene age channel, so like a river channel. Also the project ran into inclement material. So if you think about river systems, they are sinuous and they wind around and they erode down, right? They cut down into non-river systems around them, which in this case, if the past is the key to the present, it was probably a boggy marsh. So if we're actively mining material, there was a high likelihood that we could accidentally run into some material that was not beach quality sand. So we had some problems with that. And it caused us to go down from 17 miles to 14.5 miles. And we did a lot of adaptive management working with the contractor for this. And this also included us going back out into our borrow area, doing 2 additional coring surveys so we could qualify and quantify the available beach quality sand that was available in the borrow area and not run into bad material again. Another thing that is very unique about this project and this place and causes complications when it comes to construction is that the McFadden Beach is a well-known archaeological site, 41 JF 50, and we have many artifacts that date back to Paleo-Indian periods, from 14,000, before present to more recent. So we can find dart point tools, all kinds of fossilized remains, including, recent cattle bones, because we do have a ranch on the wildlife refuge, and turtles, deer, bison, horses, mastodon, and, ancient fish fossils. So this place is not only recreationally where people want to go hang out and fish, but it is a mecca for, professional archaeologists and novice archaeologists, like just wanting to get out there and search for things. Now, the complication arose with our borrow area being a likely place where the people used to live back then. So in the pilot project, we had a lot of monitoring that was required, 24-hour monitoring of our dredge material in the event that we actually mined into a prehistoric site. So in this phase, we completed a lot of archaeological research to ensure none of the cores contain likely prehistoric sites, and then we did a pre-construction pedestrian survey to look for any artifacts to show that these were not actually coming from our borrow area. And here are some of the lithics and bones that were found before the project. Since this is a really mega scale size project, of course, we had biological monitors there present during the project. And these biological monitors were really fantastic because their reporting efforts, they were our eyes and ears on the ground all the time. And they were there to ensure we didn't have any kind of nefarious activity occur with our contractors, which were really great. They did all the construction crew training, but if anything were ever, if any turtles got stranded, if any marine mammals got stranded, they called in they alerted U.S. Fish and Wildlife, they alerted NIMS, and completed all these trainings. And really one of the most impactful things that we got from the biological monitors were these daily reports with dead animals. But the dead animals were actually our markers for actually like giving us numbers and actual species that are coming on these big migratory pathways. So I think that was really, really cool. And of course, they also nested off, least tern nests and chicks, and made sure any kind of like piping plovers that were loafing, which they loafed everywhere all the time with all the new fresh material, loved it. That they were roped off and that any construction couldn't occur there And so it was just really neat. So construction, like I said, so it's hydraulic. So we closed down large sections of the beach. The beach remained closed for 2 years to the public, which made the public kind of angry, but we were putting in something that would make it much more accessible. We restored 14.5 miles of beach and dune ecosystem. And then immediately you could see invertebrate activity, critter activity in the swash zone. We started forming sandbars. We had a renewed beach and dune ecosystem. You could see crabs, you could see snakes, you could see predators like utilizing all the dunes, hunting, alligators coming out. And it was just a really powerful project and pretty awesome to see. Just immediately after we would, complete a section, all the flora and fauna would just move in and start doing their thing, and the plants would start taking a hold, and it was pretty amazing. So this also included native dune plants planting, around 160,000 native dune plants, including bitter panicum, marche cordgrass, railroad vine, sea oats, and sea purslane were planted by Res LLC. And we planted them in rows of 8 with 5-foot spacing, which sounds kind of large, but in this section of Texas, we get a lot of rain, and we figured we'd have a lot of volunteer activity, and we had to plant, almost 15 miles. So we also included some post-storm planting and adaptive management. Speaking of post-storms, like I said, this area does get hit with a lot of storms. And at the top part, we have a series of photos from this one location. This location is in the pilot project, and it is in an area where we have a hard time keeping sediment in the sediment cell. So we, like coastal planners, like to look at sediment budgets and, is sediment moving to the west? Is it moving to the east? In this particular area, we have sediment that wants to move to the west and east, and we just cannot keep it contained. So in the far left, you can see a post-storm photo after the pilot project has been completed in 2018, where this particular area still has a pretty wide beach. It still looks pretty great. And we have these posts, which, you can kind of see the posts in each photo, right? This middle photo occurred in the pilot project in the same location, post Alberto. That was just this past storm season. And we can see how these new sand flats, develop, and we have this overwash, and we start stepping back landward into the marsh, which is what we want to prevent. And then in this far right picture, it is the same location post Beryl. Beryl was a very effective storm. We were overtopped and underwater for like a period of almost 24 hours, and it was highly devastating. Other areas during the same time period, this shows fill segment number 1. We have some really stable dunes, and they were scarfed out by Tropical Storm Alberto. And then we did some adaptive management measures where we came in and we took that overwashed material from behind the dune and we placed it back up into this dune system. So really cheap, really effective adaptive management, because we want to push that overwashed, misplaced material back into a seaward place. All right, so lessons learned. We completed 14.5 miles of beach and dune. It included getting a better understanding of our burrow area before we go into it the next time, working with our contractor to better implement sediment placement and working on access and all those issues. And then we learned some really great, very cost-effective adaptive management strategies for post-storm damage for both sediment sculpting and planting. All right, next up, we have Mark Van Maurik with Johnson Beach in the Florida National Park System.
Mark, you're on mute.
All right. Can you see my first slide?
Yes.
Yes.
Okay, great. So my project I would like to present on is called the Johnson Beach Access Management and Habitat Protection Project at Gulf Islands National Seashore. And looking how to advance the slide. Here we go. Quick project summary. It had a budget of 3.2 million. NEPA and OPA compliance was covered in the 2021 Final Restoration Plan number 2 and environmental assessment document by the Florida Trustee Implementation Group. Construction was completed between September 2023 and February 2024, and it came in at a cost of 2.6 million. The Florida District of Gulf Islands National Seashore is located in the very southwestern corner of the Florida Panhandle, and the project is over here in the Perdido Key area. And I'm going to try and find a laser pointer. I don't know if I can. Not do that. And if we zoom in a little bit farther, the actual project area is this 2-mile section right here. Zoom in even more. We look at this 2-mile length of road. Visitors come in from the west here along this road. They go through the entrance station. There's a main parking lot here that has about 330 parking spaces. And then there's a 1.2-mile section of road here, a 2-lane road that holds about 400 parking spaces at capacity. And then there's a turnaround here at the end of the road. And so what visitors do is they park at the main parking lot, or they park along the road here, unload their passengers and their stuff, and they just walk through the beach dune habitat to the north or south shorelines. And it's not just this area that's being impacted. They will often drive over here to the right or the left, drop off their visitors. They'll walk through the habitat to the shorelines, and then they'll park back where they're allowed to park. There are 11 old boardwalks in this area that visitors would sometimes use, sometimes not use. And this red polygon just illustrates the shorebird habitat that was at that time unprotected. And this is where people would just walk through to get to the shorelines. The little red squiggly lines, those are known social trails, but in reality, there are social trails everywhere. And it's not just shorebird nesting habitat, this whole area is critical habitat for the endangered Perdido Key beach mouse. And this right here is really the core of the problem. So this is the Johnson Beach Road. Again, it's 2-mile length, and cars park along the road side, more often than not with 2 wheels on the pavement. So you can see how the width of the road gets narrow, so it sometimes only one vehicle can pass through the middle of the cars. Upper right, you see a emergency vehicle. That's law enforcement's biggest concern. It's not just a habitat issue here, it's a visitor safety issue. Lots of pedestrians in the middle of the road, cyclists, kids. So there are a few things that need to be fixed here. This area gets about 251,000 vehicles per year. That's the entire area, the main lot and the roadside parking area. About 732,000 visitors a year. The peak daily use, which is when every single parking space is being used, that falls in late spring and most of summer on the weekends typically, and during holidays. And if you were to just do some quick back of the envelope math, on a day with peak use, you'd have about 400 cars along this 1.2 mile section. You've got about 3 visitors per car, so that's about 1,200 visitors making a trip from the car to one of the shorelines and back. That's 2,400 trips per day to the beach dune habitat. If you assume that half those cars get replaced over the course of a day, you're looking at about 3,600 person trips per day through this beach dune habitat. And that's literally hundreds of thousands of individual trips walking through this area per year. The other part of this project is what to do with the existing 11 boardwalks. Many of them were just simply overtaken by natural dune migration, and that rendered them unusable. They're also in an extremely weathering environment, so they were splintering and just falling apart. So the solution was to manage your visitor access to the shoreline, and in so doing, protect habitat and also visitor safety. And the way to do that was to remove these little tiny purplish lines. Those were the existing boardwalks, to eliminate roadside parking along that 1.2 mile section, and to construct 3 new small parking lots on the north side of the road, each with boardwalks going to the north and south shorelines, each with fencing around them that would funnel people into those boardwalks, so they would use them and not go around them. And finally, the last half mile of the road is going to be narrowed and converted into a bicycle pedestrian path. So the obvious problem is putting these lots in habitat, in active habitat, and this is simply a illustration of where shorebirds like to be, at least between the years 2011 and 14. The colored polygons show where colonies would be located historically. Green polygons is where bird nests, chicks were often found. And this is a similar illustration, just with data taken from 2016 to 2020. Again, the green is just active bird habitat, and the blue and orange diamonds there are known nests. And the red area, you can see that there's no bird activity there. And that also coincides with the most active visitor use going from their cars to the shoreline in this heavily used area. So what is the impact of these 3 new lots on birds? Well, it's obviously not nothing. The Florida Fish and Wildlife Conservation Commission has a rule of thumb that they like to apply to bird nests and points of disturbance. And that is a 300-foot distance that they'd like to see. So if you just simply draw a big circle around each of the lots, 300-foot radius, you're obviously going to overlap some of those historical areas where birds have been found. And this was an argument made against the project, and this was a surprisingly controversial project. But what is the impact of not doing the project? You could use that same 300-foot buffer metric or rule of thumb and draw a 300-foot radius circle around every single point along the road where a car would park and where visitors would walk. And so that meant that the entire area, all bird habitat and all nests would fall in that area. It did nothing. So we thought it was a big improvement for birds and wildlife to do the project. So as required by law, we took a close look at any impacts of the project on T&E species and on critical habitat, and we got 2 determinations were made. 2017, a biological opinion was issued by the Fish and Wildlife Service that said the project may affect, but is not likely to adversely affect these 2 birds here, piping plover and red knot, and 4 sea turtles in critical habitat, and not least of which is the endangered Perdido Key beach mouse. And the BO said actions will not jeopardize BKBM or adversely modify their habitat. That was a very important determination. We also got a listed species incidental take permit in 2022 from the Florida Fish and Wildlife Conservation Commission. And that granted authorization to, quote, harass via conducting construction activities or least tern and snowy plover birds. Those were very important to the state. And these 2 determinations, once we got them, green-lighted the construction. So the final project metrics. There was a net increase in pavement of 1.36 acres. That was 3 new lots minus the pavement loss from narrowing the last half mile of the road to a whopping 0.61 acres, which is a tiny fraction of the habitat in that area. New parking spaces, there were 30 in one lot, 30 in another, 50 in another, a total of 110, which was actually 290 fewer lots. So that's fewer visitors and cars than before. And I would say it's a 95+% of foot traffic is now on these dedicated boardwalks. And this is a big deal. And so at least 113 acres of beach, dune, bird, and wildlife habitat is protected. And again, this is kind of a night and day situation. So have there been improvements in shorebirds and Perdido Key beach mouse metrics? So it's too soon to tell. It's only been a year and a half. And we're hoping to see more active nests and fledges overall in the area, in particular on the south side of the road, and a possible increase in the mouse population. Lastly, here are some photos of the project. The area was graded and cleared, of course, and they put this geogrid underlayment wherever they added pavement. That's a new state-of-the-art way of doing it. Boardwalk removal and construction took place. Put in a new sidewalk at the main lot to so that people would no longer have to walk through the parking lot to get to the pathway to the beach. And here's a picture of the newly paved lot, right? And here's a completed new parking lot on the left here, and a boardwalk going to the sound side off to the left. And here's also a picture of a boardwalk to the sound side shoreline. And this picture on the left is the beginning of the half-mile bicycle pedestrian path. You can see where they took out the other half of the pavement. And finally, this is the whole thing on the bottom right, off to the left, just out of frame, is a new parking lot. You can see the fencing that funnels people onto the crosswalk. There's a speed hump there to control speed. There's a new boardwalk going to the Gulf side, and then all the signage. And if these little critters could speak English, I think they'd say thank you. So now I would like to hand it off to Amanda Demopoulos.
Thanks, Mark. Appreciate it. I am sharing my screen currently. I'm hoping that you all can see it.
Looks good.
Thanks. Appreciate the chance to speak with you all. We're going to transition from the beach to the offshore and deep water, and I appreciate the invitation to speak today. I've been part of this effort from assessment to restoration since the 2010 Deepwater Horizon spill. And for mesophotic and deep benthic communities restoration, NOAA serves as the lead for this portfolio of projects, with DOI serving as co-trustee. Plus, we have a lot of partners involved. And in a moment, I'll dig into what these environments are composed of and our restoration objectives across the portfolio of projects, along with lessons learned integrated throughout the talk. Well, following the damage assessment, the trustees identified oil was deposited on at least 400 square miles of the seafloor of the Deep Gulf, with quantifiable injury documented over 770 square miles of benthic habitat, including substantial losses of corals and the many species these benthic habitats support. Ultimately, the settlement reached with BP yielded $273 million allocated to restore mesophotic and deep benthic communities. And I'll maybe refer to them as MDBC since we're dealing with acronym soup on a daily basis. And this represents one of 13 restoration types. This restoration type includes hard and soft ground habitats and the associated fish and invertebrates, including corals. Now, the recovery of long-lived and slow-growing coral species that make up these habitats is expected to be very slow, and restoration is further complicated by their remote locations, along with our limited understanding of key biological functions and difficulties with working at these depths. So to address these challenges, the trustees set 3 restoration goals: to restore the invertebrate and fish abundance and biomass for injured species and to provide healthy habitats, to actively manage deep sea communities, to protect against multiple threats and provide a framework for monitoring, education, and outreach, and to improve our understanding of these communities to better inform management and ensure resiliency. Thus, the vast majority of this portfolio is focused on science to inform restoration, which is unique for a natural resources damage assessment case, where often the focus is on active restoration activities. In order to meet these long-term restoration goals, the Open Ocean TIG approved 4 projects: the mapping, ground truthing, and predictive habitat modeling, habitat assessment and evaluation, coral propagation technique development, and active management and protection. Now, together, these projects comprise an integrated portfolio of restoration activities to reach long-term restoration goals. The total budget for the portfolio of projects is approximately $138 million, which is just over half of the restoration type allocation. Recently, we held a public webinar describing the achievements of these projects to date and future plans, and I'll summarize a few key outcomes today. For your reference, the geographic context and area of interest of the restoration is the Northern Gulf, from the 50-meter isobath all the way out to the 27th north latitude. And the mesophotic zone represents depths from 50 meters to around 300 meters, and the deeper zone represents greater than 300-meter depth. And just for reference, the wellhead was around 1,525 meters, which is almost a mile deep. During the planning phase, we held productive workshops with subject matter experts. We conducted data inventories and analyses, and this allowed the team to identify specific gaps and priorities for the implementation phase. The reports that resulted from this planning phase can be found on the NOAA institutional repository, where you can find current MDBC publications. The repository continues to amass more publications and products as more data are produced from the project efforts. Now, during the implementation phase, much of our time and effort goes into planning and executing several offshore missions each year, utilizing a variety of vessels, remotely operated vehicles, autonomous underwater vehicles, and divers, and other tools to collect data to inform restoration and to perform restoration activities. As you can see from the timeline, this effort has ramped up over the course of the last few years with increasing days at sea and numbers of expeditions. These expeditions encompass a variety of activities that lead to important follow-on work executed back on shore. Now, in terms of the mapping, ground truthing, and predictive habitat modeling project, the major activities that they are focusing on include mapping using the ship-based maps and instruments available on the ships, which provides relatively lower resolution data, but helps guide selection of sites for further investigation using AUVs equipped with multiple sensors that allow us to map in even greater detail. This is better illustrated on the graphic on the right, where you can see the AUV data in color, sort of color coding the seafloor and identifying the highs and lows and more refined details of the seafloor, which is highly valuable for restoration planning. The team is also using ground truthing surveys to improve and refine predictive habitat models in order to better locate specific habitat types and species across the Northern Gulf. And the project is tightly integrated and interwoven with the other projects that also rely on these data for field planning. The Habitat and Assessment and Evaluation project, through planning phase workshops, this team has identified a suite of activities to focus on for data collection. Over the last 3 field seasons, the team has made great progress on filling data gaps, including characterizing sites that were possibly impacted by the spill and those unimpacted, but they're poorly known. In addition, they're gathering data to better understand the population genetics and how species are connected across the Gulf, and improving our understanding of the environmental variability over time. Filling these identified data gaps helps inform current and future restoration, as well as the development of long-term monitoring strategy. By establishing unimpacted sites or reference sites that will be monitored over time, we can better understand the recovery trajectory of impacted sites and the impact of restoration efforts as well. Our field efforts also utilize a variety of instruments and sensors, including the Autonomous Reef Monitoring Structures, or ARM, seen here on the top, and benthic landers, seen here on the bottom. The benthic landers provide an environmental record over months, days to months of the seafloor environment in soft and hard bottom communities, while ARMS also allows us the ability to collect organisms while we're not at sea. Back on shore, the data and sample processing includes annotating imagery collected by ROVs to identify fish, coral, and large invertebrates and characterize habitats. In addition, samples of organisms are being used to identify new species and better understand how populations of different parts of the Gulf may be connected. This all will allow us to identify potentially significant coral populations that could help replenish corals at sites impacted by the spill. For the coral propagation technique development project, this team is utilizing ROVs, technical divers, and saturation divers to collect samples of corals that are brought back to the labs and aquariums to support scientific studies, including coral husbandry, reproduction, growth, and genetic studies. By developing our baseline knowledge of these target species, we can better understand how to restore populations in the wild. Teams in the field are also testing a wide range of propagation methods, including coral fragmentation. You can see this in the picture on the left, where a technical diver is monitoring a coral fragment rack, which contains small fragments of a species of coral that were collected and then attached to this rack. And over time, they will be monitored for their health and growth to determine if this method is a viable way to increase coral growth. The team is also testing the development of artificial substrates that could allow for more coral larvae to settle and grow over time. These efforts in the field also translate over to propagation tests back on land, where federal labs and partner aquariums are keeping these corals alive in tanks. We have been fortunate to witness and benefit from the spawning of corals in our tanks, which you can see in this video on the right of Swiftia excerta, which was imaged in 2023 in the lab aquarium. As a result of their high productivity, meaning lots and lots of spawns, we've been actually actively caring for the baby corals, and This has resulted from numerous successful spawning events in the tanks in our federal labs across the country. One of the oldest juvenile corals that we have in hand right now is this one in the middle. This is the one we are calling Beef O Baby. We haven't trademarked that name, by the way. This coral is at the ripe old age of 3. It's toddler, but is growing rapidly as we monitor it in the lab. As we work with these juvenile corals, we're learning from these spawning events and their ability to settle. We're understanding their diets, their feeding behavior, as you can see in this video on the right, their growth rates and how they differ among the different coral species that were directly impacted by the spill. And ultimately, this project is testing and evaluating several approaches to determine the efficacy for large-scale restoration. Activities that the active management and protection team have led thus far have helped understand, document, and reduce threats to MDBC habitats. This has included installing mooring buoys to prevent impacts to the seafloor habitat from anchoring activities. They've removed marine debris as well as invasive lionfish. The AMP team also coordinates communication and outreach efforts, documenting the work at sea and ensuring these habitats and restoration efforts are more accessible to the public. For example, 4 exhibits have been constructed at partner venues across the Gulf. This includes exhibits with live corals on display at both the Audubon Aquarium in New Orleans, seen here in the slide, and the Mississippi Aquarium in Gulfport. These exhibits provide a window into parts of the Gulf that most people never get a chance to see. And this is only a snapshot of the activities and web stories that the team has been able to support during the implementation phase. I'm almost to the end of this presentation, just to let you know that while 2025 fieldwork is underway, this year the teams are starting to work on data synthesis efforts, which will continue through the closeout phase in 2028. This effort will help us develop a higher level understanding of what the data tell us about the extent of these habitats across the Gulf, how they are connected both spatially and ecologically, as well as specific outcomes of the project and how this information guides restoration efforts and natural resource management. All of this information and synthesis will help inform the MDBC restoration work that is still yet to come. This portfolio that I've described will use a little more than half of the total MDBC allocation, and the development of a supplemental restoration plan has begun. This plan will outline additional restoration work that will extend into the late 2030s and 2040s using the remaining MDBC funds. This work will include similar project activities, but rescoped with an emphasis on direct restoration efforts such as coral propagation methods and threat reduction. Now, each June, a catalog of the portfolio's data and publications is published at the same time as the annual project reports. And this is easy to navigate to from the Open Ocean Restoration Area page on the Gulf Spill Restoration website. This is also a great place to find annual project report on the documents page. Now, I welcome questions today, or please reach out via email. And now we'll turn this over to Mary Josie Blanchard to kick off the question session, what we have time for. Thanks.
Okay, I'm not sure if there are questions or, I think any of our speakers are very happy to be able to answer. And Christian, I don't know.
Yeah, so we are just a little over time, but I want to take just a couple minutes to allow you guys to answer maybe a couple quick questions and then ask you guys to go to the Q&A and answer maybe some of the ones that might be more detailed. So hopefully just it's a quick answer. What's the typical long-term monitoring timeline for these projects intended to be funded with settlement dollars, 20 years or more or less than that?
I can speak to this a little
go
bit.
ahead.
Mary Josie, and you can fill in after me. For the North Breton Island Restoration Project in particular, our monitoring timeline is about 10 years. And that was mainly, I think, just to help give us a really full long-term picture of what restoration did to benefit bird populations that utilize that habitat. and to measure productivity within that time frame. But I think this varies widely depending on the type of project and the restoration type or goal that you're trying to focus on.
Yeah, our project was 3 years, a lot smaller, a lot more modest.
So the typical answer for NRDAR, it depends. So maybe you can answer quickly. How often do folks monitor for nest disturbance by people, ATVs, and dogs?
I think
Well,
that might
my
be directed
project
to you,
is-
Mark.
Yeah, okay, it was every 2 weeks. They survey for all nesting shorebirds through the entire bird nest season every 2 weeks.
Okay, thank you. And then can one of you answer what is the protection status of the snowy plover?
It's a state listed species. It's not federally listed, and the state is really keen on that bird. And so I don't know the term for their level of protection, but it's high.
Awesome. If there's anybody who wants to come off mute and ask a quick question, please raise your hand. This other one might be a little bit long, but I'll let the speakers know about it, and maybe you want to go and type a chat. But someone was talking about a story being run about beach nourishment being a waste of money. And are there any best management practices for increasing longevity or cost effectiveness, and or maybe outreach strategies to develop local support among the public?
Hey, that was for me. Sorry, again, my camera is not working. I keep pushing camera and it just rejects me. So I don't know what's going on. But anyways, I was the one that presented on McFadden, and our project was one of the first projects to utilize a offshore, not in America, but in Texas, for us to utilize an offshore borrow area, which was pretty key in us like taking the reins and controlling coastal erosion on a state level. The story that is posted here is pretty interesting, and it talks about federal use and federal dollars going towards beach nourishment with the Corps of Engineers. Speaking only towards Texas, we work very closely with the Corps of Engineers. So the Corps of Engineers has to maintain, commerce, and they have to maintain maintenance of all the channels, the navigation channels. And so what they do is they spend millions of dollars dredging those navigation channels, and then instead of putting the material beneficially on the beach, they dump it into dredge material placement areas, which are either offshore in an OMDS or they're on some upland structure. Now, the Corps of Engineers has run out of their DMPAs in place to store this material. So we have got a lot of initiatives with them called BUDM, where we beneficially place this material onto beaches or marshes. So just imagine spending millions of dollars and just throwing that sediment away instead of the states or local partners coming in and paying an incremental cost to place it back on the beach. Now, this tends to cost us about $400 to $600 per linear foot of placement. This is our best bang for our buck. It's highly effective. I cannot comment on what this news story says, but the feds are literally not paying in Texas for that beach placement. We come in and we pay for it. So they're mining their navigation channels and we pay to place it on our beaches. The problem with this is it only is effective for those places that are next to navigation channels. So your South Padre Island, your Galveston Island, and then we will be working with them to do something closer to where the McFadden is on our other National Wildlife Refuge, which is Texas Point. So if you're thinking of 367 miles along Texas beaches, and only 2 of those beaches can effectively be nourished with this beneficial use program, then you've got another problem, and that's how do I get more sediment to the beach, right? So in my opinion, beach nourishment is costly. Looking at McFadden and showing you that one area where we essentially eroded back almost to pre-project conditions within 10 years. In my opinion, that's really successful. We are looking at long-term ways to help these areas that are highly eroding. That might involve some sort of shoreline protection structures like groins or something that are going to keep the sediment in place, that is extremely expensive. And in the short term, beach nourishment and us continuing to move forward and really revolutionize how we're handling coastal erosion in a holistic manner is way more effective in this space. And I think, you know, a lot of the other measures, but we are actively looking at, well, what do we do in as far as, you know, keeping stuff in place. So that is it's a long question you could probably talk about for an hour, so I will stop. But yeah, we're
Okay.
aware of everything.